look at the worksheet 3.4, part B. It uses a rational zero theorem. Okay, it says we're given a function and we're asked to first list the possible rational zeros and then all other zeros and then finally factor into linear factors. Okay, so let's start with the first part. Let's use a rational zeros theorem to list possible rational zeros. Okay, so if we look at this definition, the rational number P over Q is defined where P and Q are prime numbers, where P is a factor of the constant term, which is 6. So let me just kind of list those factors. Okay, so think of prime numbers that go into 6. That'd be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Okay, that lists factors of P. Now let's go to factors of Q. Q are factors of the leading coefficient, so right there, which would be 2. The only factors of 2 are plus or minus 1 and plus or minus 2. So now what we have to do is we have to list all possible P's over Q's, all possible rational zeros. Okay, so let's do this. Let's start with 1. This is a P over a Q. 1 over 1 is 1. Okay, let's go from there. 2 over 1. And again, I'm including the plus and negative. 3 over 1. 6 over 1. Okay, now we're going to get to the 2. Let me get you a different color here. Okay, 1 divided by 2 plus or minus 1/2. 2 divided by 2 is 1, which we already have listed. 3 divided by 2. 6 divided by 2 is 3, which again we already have listed. So these are all of our possible rational zeros right here. Okay, now let's actually try one of them. I'm going to start with 1 as my very first zero to try. Let me erase this first. Okay. Okay, so I'm going to try 1. Okay, I'm going to divide this polynomial by x minus 1. If I get a remainder of 0, then I know it's a factor. If not, then I have to try a different number. So let's go ahead and put the polynomial in here. So I have 2, negative 3, negative 11, and 6. Okay, now let me go ahead and try to divide this. Okay, I bring the 2 down. 1 times 2 is 2. Negative 3 plus 2 gives me negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 11 gives me negative 12. 1 times negative 12 gives me negative 12. So I end up with, looks like a negative 6 here. Okay. So according to this, since I don't have a 0 here, that means basically 1 is not a 0. Okay, so let's try another number. Let's try negative 2 as my next number. Okay, so again, I'm using my original polynomial. Using synthetic division, I bring the 2 down. Negative 2 times 2 gives me negative 4. Negative 3 plus negative 4 gives me negative 7. Negative 2 times negative 7 gives me a positive 14. Negative 11 plus 14 gives me 3. Negative 2 times 3 gives me negative 6. So I get a remainder of 0, so that's good. So negative 2 is a 0, and I can rewrite my polynomial as x plus 2. And then this polynomial, which again would start off with an x squared, 1 degree less than the original polynomial. So it'd be 2x squared minus 7x plus 3. Okay. My next step would be, since this is a second degree of polynomial, is to actually set this equal to 0 and solve it. You can use a quadratic formula or you can factor it. This one does factor, so I'm going to just go ahead and factor it. So I get x plus 2. Actually, I'm going to write down here a little bit further here. Okay, there we go. Okay. So I get x plus 2. And this factors to 2x minus 1 and x minus 3. Okay, so this gives me the 0 of negative 2. This gives me the 0 of 1/2. And this gives me the 0 of 3. Okay, so now let's go back and make sure we answer the question. Okay, A says find the rational zeros and all other zeros. Okay, so these are all the zeros right here, and they're all rational. So this answers the part 1. And then part 2, factor into linear factors. We actually did that right here. This is part 2. Okay, so this concludes this worksheet.